Hello students, welcome back to the channel. Get understanding, don't memorize. This is the continuation of a series of lessons on binary operation. Binary operation in further mathematics or elective mathematics. Okay, further mathematics or elective mathematics, binary operation. Yes, we are still looking at what properties of binary operation. Properties of what binary operation. In the previous lesson, we looked at what the commutative property. In this video, we are going to look at what the associative property. Okay, so we are saying that binary operation triangle defined on the set of real numbers R is associative. So what you realize, the difference is that with the commutative property, you only take two elements of the set on which the operation is defined. You take only two elements. But with the associative property, we take what? How many elements? Three elements. You take three. So here, what is the operation? The operation is what? The operation is triangle. Okay, and triangle is defined on what set? The set of real numbers. Have you seen? And how many elements are we taking from the set of real numbers? We are taking three, which are A, B, and C. So for we take every three, any or every three elements. For every three elements from the of the set of real numbers, if we take every three elements of the set of real numbers, then if A, triangle B into bracket or triangle C is equal to A triangle into bracket or B triangle C. For every three elements, A, B, C belong to the set of real numbers. Then we are saying that the operation triangle is what? It's commutative. It's associative. Then we are saying that the operation triangle is what? Associative. So yes, so that is what we are saying. Here we are saying that you have to get it quickly, because we are saying that with the commutative property we take only two elements, but with the associative property we take what? Three elements. Have you seen? So we are saying that if you have this operation triangle, you have this operation triangle, then we are saying that the operation triangle is associative. Associative if what? So we just write, if we are taking three elements, A, B, and what? C. Can take S, Y, Z, or T, M, and R. So we take this from the set of what? Any three elements from the set of real numbers, and the operation is what? Operation is triangle. So we can just write A triangle what? A triangle, B triangle what? Triangle C. So if this is equal to, you have the same thing, A triangle what? B triangle what? C. Have you seen? So if then you put bracket around the first one, the first two, then if you go to the next side, you put the bracket around the last two. Okay. So if you can also write it as what? A triangle what? B triangle what? C. If it's equal to A triangle, B triangle what? C. If you like, can put the bracket around the last two here, and then if you come here, you put the bracket under the first around the first two. It doesn't matter the position. So what we are saying that we have three elements, and you are going to use the operation triangle to evaluate them. So if you evaluate the first two, and the answer you get, you combine it. With the third element, and then you get an answer. You put the answer down, and then if you want the last, you evaluate the last two elements first, and using the last two elements first, the answer you get, you combine with the first element, then you get an answer. If you compare these two answers and they are the same, then we are saying that the operation of what? Triangle is what? Is associative. The operation triangle is what? Associative. It's not difficult at all. Know this. You have to know how to write. Maybe how to write this might confuse you. That's why I'm trying to write it simply for you to understand. What you have to do is that with the associative property, we are saying that we take three elements. We are taking three elements. Three elements with what? With only one operation. But with the commutative property, we take two elements with what? With only one operation. So we are taking three elements: A, B, and what? A, B, and C. So we are saying that the operation we are using is what? Is what? Triangle. So A triangle what? B, then triangle what? C. Because we are taking three elements. So we are saying that if you have these three elements you want to evaluate, then we can evaluate the first two. If you get the answer you get, to combine with the last element that you evaluate. Or if you like, you can also evaluate the last two. So A triangle what? The last two, B triangle what? C. If you evaluate the last two, the answer you get to combine with the first. So we are saying that irrespective of how you evaluate the order. So if after evaluating this whole thing and evaluating the whole thing on the right answer, if they are equal, then we conclude that the operation triangle is what? Is commutative. And then we are saying that the order as normal, somebody can also decide to evaluate the last two first. That is, we put the bracket here before and evaluating what the first two on the other side. Obviously, yes, somebody can have this. So if you have this, if this one is also equal to this, then we can conclude that the operation of what triangle is what associative. Yes. So that's what we are saying. So I said the binary operation triangle defined the set of real numbers R is what associative. If what A triangle B into bracket or triangle C is equal to A triangle into bracket B triangle C. For all A, B, C belong to what? If you take every three element from the set of real numbers, if this is this whose for every three element from the set of real numbers, then we can conclude that the operation triangle is what associative. Note that for all A, B, C belong to R. Yes, so we are looking at what the operation of what operation of multiplication under the set of real numbers. For all A, B, C belong to a set of real numbers A times B, you are going to multiply these three elements or numbers A, B, and C. Have you seen? How do you multiply them? You can multiply the first two A, B first. The answer you get to multiply by the C. Or you can multiply the B, C first. The answer you get to multiply by the E. So what we are saying that after multiply, if you choose this order and you find the multiplication, the answer you get, and then if you take this order, multiply, the answer you also get. If you compare the two answers and they are equal, then we are saying that the operation of the multiplication of what real numbers is what is associative in this case. But you know, yes, this one is very true. You know that if you have three numbers and you are multiplying, irrespective of how you multiply, if you multiply first two, the answer you get to multiply by the third one, or multiply the last two, and then multiply the answer you get by the first one, you are going to get the same answer. So we are saying that note that for all A, B, C belong to the set of real numbers. A times B, the answer multiplied by C is the same as what? B times C, the answer multiplied by A. You get this one is always true. And then we are saying that if you are using the set of what? The same set of real numbers, and we are using the operation of addition. Then you take three elements or three numbers from the set of what? Real numbers. If you are adding the three numbers. So you can either add the first two numbers, and the answer you get add it to the last number. Or you can add the last two numbers or elements. The answer you get add it to the first number. So that's what we are saying. And this one, you know that this one also hold for. So let's take these numbers. You take 1, 2, 3 from the set of real numbers. What if you multiply 1 times what? 1 times 2 times 3. Is it not the same as what? 1 times 2 times 3. So you can, if you are multiplying the 3, you can multiply this first. Irrespective of how you do it. So 1 times 2, what do you get? You get 2 times what? Then 2 times 1 times 2, 2 times 3. What do you get? You know 6. And if you multiply the last two first, 2 times 3, you get what? 6. And then 1 times 6, you get the same 6. So have you seen? So yes, this is holding. It will hold for all the numbers of real numbers. For all the elements under the set of real number. If you take every three elements you pick from the set of real number to hold. The same way if you are adding these three numbers, then if you are adding, then you know that 1 plus what? 1 plus you got 1 plus 2. Then plus what? Plus 3. Is it not the same as 1 plus 2 plus 3? Check. Whether you not get the same. What is 1 plus 2? 3. 3 plus 3 is what? 6. And this one, 2 plus 3 is what? We get 1 plus 2 plus 3 is 5. What is 1 plus 5? Is it not 6? So you see. That's what we are mean. I hope you get the explanation. It's very simple, it's not difficult at all. So yes, so we are saying that's what. Therefore, addition and multiplication of real numbers are associative. Addition and multiplication of real numbers are always associative. We also have to note also that for any trace set P, Q, and R, if you have trace set, you want to find the intersection of the trace sets. You can find the intersection. You want to find P intersection Q intersection R. This is what you want to find. Finding the three at the same time I confuse you. You can decide to find the first two first. The answer you get, you combine it with the last set R, and then you find you get the same thing. And somebody can also decide to find the last two first intersection Q intersection R first. The answer you get, you combine it with the first set P, and then find the intersection. You will get the same answer. Give yourself examples. It is define set PQR, and then you find. Just verify yourself. That's how you learn and get your own understanding. You see, you understand it better that way. So irrespective of what you do, this one will always be equal to this under what? Under the set, the set of set. And then if you also take the union, you have P, Q, and R. You want to find the union of these three sets. You either find the first two first, the union, and then the answer you combine with the last set, or you find the last the union of last two sets, then you combine the answer with the first one, you will get the same result. This one will always hold. So what have you said? We have said hence intersection and union of what of set are also are associative. Yeah? Intersection and union of set are also associative. Yes, guys, it's not difficult at all. It's not difficult. It's not difficult. So that's what I mean. You can just give yourself what examples. Give yourself examples. As I use what I use the numbers to explain that. This one. Let me also use the set to explain. Okay. Let me define that simple set and explain. You understand it. This is simple. So let's say we have the set P. P is equal to let's say 2 and 4. Okay. Yes. Okay. And then Q is also equal to 2. Let's say 6. And then we have R is equal to what? R is equal to 1. R is equal to what? 1. Let's say 1. Is what we have. Okay. Fine. You want to find P intersection Q intersection R. This is what you want to find. So if you say P intersection Q intersection R, the same as it means that elements that belong to all the three sets are this. That are common to all the three sets. Amazing. But instead of finding the three at the same time, you can decide to find what. First of all, find P intersection or Q first. You combine these two, P intersection Q. What do we get? P intersection Q get is 2 and 4 and 2 and 6. So the intersection element common to P and Q will get what 2. This is what we get. And then you combine this answer with what? With the set of what? R. So R is equal to what? 1. So what will be this P intersection Q or intersection R? What will be the answer? Element common to both. You don't have any, so you get a null set. Have you seen? This is a null set. Have you seen? Yes. So that's what we mean. In the same way, somebody can also find this one P. Somebody can find P. This P what? P. Q intersection R first. Then before you come and combine. So what is Q intersection R? This is Q and R. What you don't have any element that is common to both. So you get a null set. And then we combine this null set with what? P. So then we have P intersection Q intersection what? R. So what is this is null set, and then P is a 2, 4. What element belong to this set? Q intersection R and then P. You get what? Null set. Have you seen? So at the end of the day, don't you see we have got null set and then we have also got null set here. Are they not the same? They are equal. Yes, that's what we mean. So if you find the union of the three sets, the two, you get the same answer. That's what we are saying, guys. This is not difficult at all. If you find the union of this thing, you get the same one. You get the same answer, guys. So that's what we mean. It's not difficult at all. It's very simple. Simple and interesting, guys. It's very simple and interesting. It's not difficult at all, guys. It's not difficult. Okay? Yes. So that's what we are saying. So let's look at the union quickly. Let's look at the union quickly. Okay? Let's look at the union quickly, guys. So union, we are saying that you are finding the union, the three P union Q union hot R. You are finding the three at the same time. Somebody can find the first two first. So what is P union? So what is P union Q? P union Q. Union means write all the elements without repeating. So 2, 4. So 2, 4, 2, 6. You write 2 once to get 2, 4, 2, 4, 6. This is what you get. This. So this is P union hot. Union is Q. This answer then union hot. Union this R, which is what? 1. Union 1 R. So you get what? The answer you get is 1, 2, 4, 6. You have to rearrange from the smallest to the highest. So you get this as what? P union Q union hot R. Somebody can also decide to find what? Instead of this guys P union Q union hot R, you find the 3. You find the last two first. So this will be P. What is P union hot? What is Q union R? Q and R. So 2, 6 and what? 1, 2. You get what? This is 1, 2, what? 6. Is what we get. Okay. So what is P? P is what? 2, 4. 2, 4 and then union what? 1, 2, what? 6. Okay. So what do we get? The union. We get what? The answer will be what? 1. So we get 2, 4. 1, 2, 6. So we get 1, then 2, 4, 6. Have you seen? This is what we are. Is it not the same as this one? The same as the first one. So guys, this is what we mean. Yes, that's the explanation. This is a practical example for you to understand. Understanding is fun. Have power over understanding. You have understanding, you can do all things. Guys, hope you are enjoying. Don't forget to subscribe to the channel and share if you are really benefiting. and like it. Thank you for watching and see you in the next video, guys.